Hey everybody, let me try to do implement for quick sort algorithm in this video. So to get started, I will just create a new class. I will name it quick sorting. So here you go. I will say quick sorting. Okay. Make sure to create main method if you want. If you don't want, don't create it. Okay, I would create it because I need it. So yes, here you go. And I have here when I want to work. So to get started, I would just define my method. I say I name it static, void doesn't read anything. I would name it quick sort. Okay, and this method will take the array, integer array, and take two things. Take integer low and integer high, because I need the high index and low index to the in the array to get the pivot. So here you go. I have high and low. So let me start one by one. So first of all, to when I should stop if there is any problem happen, I would say if the low be greater than high, that's mean hey, you out of range, you did a lot of work and you done. So if this point happen, that's mean no longer search, I should return. So I just stop the work. It's because return, hopefully, yeah. So that's mean you passed the index. That's mean you have search space and you went outside the search space. Now let you think about the middle. So how you find the mid? Mid should be same thing, will be low plus same thing in the binary, high minus low over 2. This is how the rule for the finding mid element in the array. According to this one, I will define the pivot. So pivot should be come from array for mid, because the pivot is the middle element. So yes, so now you say, okay, I have this row, I have this array. For example, I select this one to be a pivot. So now let we start to think about how we sort this side and how we sort this side to make any one here greater than pivot and any one here less than pivot. So how I do that? I just go here and say, okay, you done this. Let me suppose I integer I equal the low element and integer j equal the high element. Okay, now I say while, okay, I raise than or equal j, that's mean I'm in the size, so the line doesn't pass, that mean that I didn't get greater than high, same as this point. So continue. So what I need from this one, it's hey, any move here until you find any element greater than the pivot, and move here until you will find any element less than pivot to make a switch between this one and this one. So I would say, okay, while array for I less than pivot, if it's less than pivot, I don't have any problem, I plus plus, continue. Then same thing you would do for the second one, for the someone greater than pivot, you say while array for j, if it's greater than pivot. So also I don't have any problem for j, so j have to get minus, because yeah, continue here and continue from this side if there is nothing less than, and continue from this side if there is nothing greater than. When you find anything greater than or less than, stop, because you see this is the condition. So when he stop, I need to do swap between this element. How I do swap? I came here, I say hey, if I greater than or equal j, then make this a process. Take integer temp equal array for I and array for I, add array for j, then you say array for j equal temp. I just doing swap. Make sure if I just have this array and I have the pivot here, I have this element and this element, get swap between them. So now I need to move the pointer here and this pointer here. The pointer, I mean ij. So I would say I plus plus, so move I here. So I just move it I here, and j also I need the reduced one, so I say it should be j minus 1. Here you go. So this is basically how the process goes. In some way, now I just get order only this one and this one. Now I need to go through this part and do same thing, pivot, and I go through this part and do same thing for pivot, and continue, do backtracking. So how I do that? I say yes. I just done from this loop, this while loop. Hopefully this while loop I just get it. Hopefully this one, yeah, here you go. This is the while loop. So I done from the while loop. Let me say, okay, I say if low less than j, that's mean do backtracking. That's mean take left side, say quicksort, the method name, send it the array and send it the low with instead high send j. That's mean, hey, I have this array. Now I get pivot, I sort this side and I sort this side. Now I want to send only this side as backtracking to get sorted. So I take low with j. Okay, same thing I would do for the high. Say, okay, if high greater than I, so same thing, say a quick sort. I will send array, I would say I with high. Okay, so I would send the remain part. I would send, okay, this is the pivot. Now take this part, all those to reserve or do backtracking with it and continue. This is basically how a quick sort works. Then when you're done, you sort it. So now I have this quick sort algorithm and everything is good. So now I need to send data to this quick sort to start searching. I already have bubble sort and I have main method for bubble sort. I would copy it because I would use it in other places. So this is main. I just copy the main only. Go to quick sort. I don't need to repeat the code. Remove the main here and replace it with this main. And this quick sort, if you remember, I just define array. Printed array before sorting, then call bubble sort. Now I will not call bubble sort, I will call quick sort. Okay, so call quick sort, sending array and sending low index should be 0, and what the high index should be array dot length -1, last element in the array. And here you go, after sort he will give you printed for you. So here you go, see after sort 1, 10, 13, 15, 16, 18. Again, still quick sort give you an square for sorting, because if you see there's many backtracking happen, not many backtracking, as we said, in worst case scenario, all the element, the array doesn't get split, still the array continue, element is still less than the pivot, so you will not, this is the worst case scenario. But many research find that quick sort give you a result faster. So yes, here we done, and thank you for watching.